In this lesson, in just 15 minutes, you will learn the basics of the Blender program and create this cool animation. The first thing you'll see when you launch the program is a large 3D viewport window containing a cube, a lamp, and a camera. In the top right corner, you'll find a small outliner window where we can clearly see the entire scene structure, and directly beneath it, there's a properties window where various parameters for your objects are configured. To rotate the camera within the 3D view window, you simply need to hold down the mouse wheel. To adjust the zoom level, press and hold Control and then scroll your mouse wheel. Alternatively, you can simply scroll the wheel to change the scale in predefined increments. To move the camera view, you need to press and hold Shift and then scroll your mouse wheel. Before we begin creating our scene, let's go ahead and remove all unnecessary elements. To do this, simply select all of the objects and then delete them by pressing the X key. Let's add a text object into the current scene. Press the Tab key to enter text editing mode, and then we will type the number 1 here. By default, the font for the text isn't particularly attractive, so on the Text tab, we will select any other one that we find more pleasing. The specific font that is being used in this lesson can be downloaded from the description provided below this video. Now, we're going to create a little thickness for the numbers. After this step, we'll proceed to add a bevel to its outer edges. At this point, our numerical figure will be fully prepared, and we can then begin the process of creating the glass element. To start, we'll introduce a new flat plane into our working scene. Subsequently, within the Modifiers tab, we will then add the bevel modifier. By default, it operates on edges, but we will change its working mode to vertices. We'll adjust the bevel size and then increase the number of segments so that the corners become perfectly smooth. After that, we'll add a solidify modifier to give some thickness to our plane. And then we're going to add one more bevel modifier, and in the standard edge editing mode, we will create a small chamfer. In the 3D view window, with your object selected, right-click and choose Shade Smooth to smooth it out. After that, make sure to enable the Harden Normals option so that flat areas remain unsmoothed. Now rotate the camera by holding down the Alt key to snap to the right view, and then switch to orthographic view. With it, objects appear as they truly are, without any perspective distortion. Using the N key, we'll open the side panel containing the main object parameters. Rotate the plane 90 degrees using the R key. While rotating, hold down Control to rotate in 5-degree increments. Then, we'll press the G key to move the object, and then Y to ensure it moves exclusively along the Y-axis. We'll rotate the digit in precisely the same manner. From the top view, we make the digit larger and position it in the center of the object. Let's enable object transparency. We'll check from every single angle to make sure it's exactly how we need it to be. We will make the bottom window larger and replace it with a shader editor. We select a plane and then assign a standard material to it. It's already preloaded in Blender, so we simply choose it from the available list. We'll delete the principled BSDF node, press Shift plus A, and in its place, find the glass node. Connect this node to the surface input. Now, to begin seeing the results of your material adjustments, you'll need to enable image rendering within the 3D viewport. On the Render tab, replace the Eevee rendering engine with Cycles, and if possible, designate your graphics card as the computational device. For it to become available in this menu, you will need to select your specific graphics card within the settings under the System tab. We will set the preview quality for the 3D view window using the final preset, and then we'll return to the material settings. The color designated for the glass is A38AFF. Roughness level is 0.35. Now we select a number and then create a new material for it. In the emission menu, we set the strength value to 5 and our number begins to emit white light. Let's add a camera to the scene. In the View menu, we will move the camera to align with the current view. On the Output tab, we will then set a square resolution for the camera. On the Camera tab, we will set the focal length and then darken everything that does not fall within the camera's field of view. Let's select the lock icon, and now, by adjusting the view within the 3D viewport, we can position our camera directly in front of the objects. On the World tab, we will completely disable all lighting. Now our entire scene is dark, and only the number itself emits light. By dragging the left corner to the right, we will add another 3D view window. In the right window, we will remove all unnecessary elements in the sidebar and the toolbar. Scroll the header at the top with the mouse wheel and turn off all the extras. In this window, we're only interested in the final render. On the left, unbind the camera from our view using the lock icon, then scroll the scene to exit camera view. Now let's set up the lighting with lamps in our scene. We're going to add the first area lamp to our scene, then we'll raise it up using the G key along the Z axis and increase its size by pressing the S key. Next, we'll shift it backwards and a bit to the side. Finally, we'll rotate it to point towards our objects. And then, on the Lamps tab, we adjust its light intensity and spread angle. We're adding the lamp again. We're going to shift it back and sideways. For this, we're going to assign a blue color. We'll change its shape to a disc, and then we'll also reduce the spread. We are now adding the next lamp to the setup. We position it at the bottom and a little behind the objects. We are going to make it a little bit larger, and then we'll adjust a bluish color for it. The intensity and spread. And now we'll be adding 3 more lamps with practically identical parameters. We'll place the first one at an angle, positioning it behind, and then stretch it out using the S key, followed by the Z key. Following our usual procedure, we'll adjust its color, its strength, and its spread. We will duplicate this very lamp using Shift D and then position it in front of the objects. We increase its power to 200, and then we duplicate this very same lamp once more. Positioner mirrors, positioning it directly above the objects. All of the settings will remain completely unchanged. To bring some order to our scene, we'll select all of the lamps in the outliner window by holding down Shift. Then, in the 3D viewport, we'll press the M key to create a brand new collection. Let's name this collection Lamps. Now the entire scene is much better structured, and we can deselect everything. We are now going to work on the image post-processing. To begin, we need to select the camera option in the viewport shading menu. This will allow us to see the post-processing results directly from the camera's perspective. Let's switch from the shader editor to the post-processing editor, then click New to create our initial node setup. We'll drag the first chromatic aberration effect into the editor and connect it. We'll set its value to 0.1. Let's press Shift A and start typing Bloom to find the Bloom node. Also, we connect it and use it to set up the glow effect in our scene. And the last third node is RGB curves. With the help of this curve, you can make some minor color adjustments to the image to suit your own personal preference. The only thing left is to create a rotation animation. We'll then add a so-called dummy object to the scene. We'll enable transparency, then select both of the objects, and finally, the empty object itself. After that, we will parent these objects to the empty, and they will begin to replicate all its transformations. We'll replace the post-processing editor with the timeline editor. Set the animation duration to 210 frames. On the Output tab, set the animation playback speed to 30 frames per second. This will result in 7 seconds of animation. Within the program settings, on the Animation tab, change the interpolation type to linear. By doing this, your animation will play back at a consistent, stable speed, free from any unwanted accelerations or decelerations. Now, with that in place, you are all set to begin the process of setting your keyframes. With the dummy selected, and while you are on the very first frame, right-click on the Z-axis rotation and then choose the option Instant Single Keyframe. Then, navigate to frame 211, set the value to 360 degrees, and right-click again on the Z-axis rotation, then select the Instant Single Keyframe option. This way, we will create a perfectly looped rotation animation. The scene is now ready, and we can begin the process of final rendering. On the Render tab, within the Render menu, you need to set the number of samples and the noise reduction quality for the final render. For less powerful computers, set the max samples value down to 512, or or even to 256. On the Output tab, specify the folder where the video file should be saved. Specify media type, video. Use the MPEG-4 container and specify perceptually lossy quality. Before rendering, save your project, and then in the Render menu, select Render Animation. Depending on your computer's processing power, this process will take anywhere from a few minutes to several hours, and ultimately, the final video file will be located in the folder you designated. Well, there you have it. I truly congratulate you. You have just learned the very fundamental basics of Blender and successfully created such a beautiful video clip. Thank you so much for watching. Please make sure to subscribe to the channel, and I'll see you all in the upcoming lessons.